Okay, this is a video of some solutions to the last three questions of a revision sheet that I had given you guys. So I'll write the questions for you anyway, and you can take a look at how they develop. This question, it's a question 12, and the question says divide 2x cubed minus x squared minus 12 by x minus 2. So I think the first thing here is that you'll notice there's no x term listed, but I am going to put in a plus 0x, because what that means is that all of the x squareds and x cubed and x, they'll all be kept under, and constants, they'll all be kept underneath each other. So when I go to set this question up, I'm going to put in my long division symbol. I'm going to put in 2x cubed minus x squared, but I'll put in plus 0x minus 12, and then on the outside I'm dividing in by x minus 2. So front into front, so x into 2x cubed is 2x squared, and I'm going to multiply that back down. 2x squared by x, that's 2x cubed. 2x squared by it's minus 4x squared. Draw your line, change the signs. There'll be a little bit of cancelling there for you. So you've got minus x squared plus 4x squared, so that's 3x squared plus 0x. Just drop the 0x down and just begin the process again. So x into 3x squared, that's going to be plus 3x, multiply it back down, so 3x squared, and then 3x by minus 2, that's minus 6x. Draw your line, change the signs, they'll cancel again for you. 6x minus 12, and begin the process one final time. X into 6x, so plus 6, and you can see there that'll work out nicely for you. Okay. So that was the first question that you had to do. The next one then, and it's number 13 on the revision sheet. It's just to simplify, and tricky enough algebra involved. A over b all over a minus b minus a minus b all over a plus b, and the whole thing is being divided by 1, and I'm going to stick that 1 over 1 just so that I'm very clear on what's going on. A minus b all over a plus b. So I suppose looking at that, the bits that I'm interested in is, well, it's a compound fraction first of all. The bits that I want to get rid of would be anything that's on this row and anything that's on that row. Okay, so the denominators of the denominators that belong to the numerator and the denominator that belongs to the denominator. So a nice easy way to deal with that is multiply above and below by a minus b and a plus b. So, too much space left, but I'll see how we get on. What's important to remember here is that, and I'm going to slide it in here, you're going to have an a minus b, an a plus b there. You're going to have an a minus b and an a minus b, plus b there. You're also going to have the same thing here, a minus b, a plus b, and a minus b, a plus b. So what's the reason for doing all that? Well, that will cancel with that. The a plus b will go with the a plus b. Nothing is going to cancel here, okay? But the a plus b will cancel with the a plus b here. So I'm just going to tidy it up and then I'll bring it over. So I'm going to have a plus b by a plus b minus a minus b, a minus b. So that's coming from here and from here. All over a minus b, a plus b, plus, and just tidy this a little bit here, a minus b, a minus b. What's important to notice here is that we'll say this part of the numerator and this part of the denominator, they don't cancel with each other. Okay. So I'm going to take that over onto the next page. Okay, a couple of things that are probably interesting to note. The top line of that is actually, you could actually rewrite that as the difference of two squares. So that's a plus b all squared minus a minus b all squared. I'm not going to do it this time because I'm going to do something different, but it is interesting just to note, and you should be on the lookout for things like that. On the top line, or maybe I will do it, I don't know. Let's maybe do that with the top line. So see where it takes us. So I'm going to have first plus second, first minus second. So I'm going to have a plus b. Sorry, a plus b plus a minus b. So there's my first. And just so you can see here, this is the first, this is the second. And then I'm going to have first minus second. So that's a plus b minus, but just watch your signs here, it's going to be a minus b all over. Along the bottom here, I'm just going to factorize out what I can here. So I've got an a minus b common to both. So that'll be a plus b and then plus a minus b. So this top bit here, well, the b's will cancel away for me, so there's 2a. That's a minus a plus b, so the a's will cancel and I'll be left with 2b all over. You can see here the b's will cancel for me, so I'll have a minus b and add my 2a's, there's 2a, gone, gone, 2b all over a minus b. And there's your final answer. So that's a Leaving Cert question, one of the old Leaving Cert questions. I think it was a part C, maybe a B part 2, which means the standard of it will be quite high. Okay, so we've one more question to do on this. It's question from the revision sheet. It's called question 14. It says x squared minus t is a factor of, and you've got a cubic, x cubed minus px squared minus qx plus r. Now hopefully you can see straight away there I'm going to put in a 0x, a plus 0x, because I'm probably going to do some division on this. First part of the question says show that PQ is equal to R. I'm not going to get too fussed about what I want to show just for the moment. I think let's just try and get the division done and see where it takes us. So x cubed minus px squared minus qx plus r, and I'm going to divide in x squared plus 0x minus t. So x squared into x cubed, that's going to give me an x, so I'll have my x cubed minus 0x squared minus tx. And I'm going to draw the line and I'm going to change all the signs there, so plus, plus, they'll cancel for me. Minus p plus 0, so that's minus px squared. And then this is where you have to get a little bit clever, I suppose. Minus q plus t, just put it in a bracket and stick your x there, and that r then is going to drop down, and you're just going to start the process again. X squared into minus px squared, so that's minus p, multiply back down, so minus px squared plus 0x, and then minus p by minus t is plus pt. So I'm going to stick with what I know to do. I'm going to draw my line. I'm going to change all the signs. They'll cancel for me. So what I'm left with is, I suppose, what should happen. There's lots of letters involved, but what should happen is, really and truly, 0x squared plus 0x plus 0. That's what I should end up, because I am told it is a factor, so I know the remainder will be 0. What you have to see from here, I'm just going to take this little piece out here. That really means that r minus pt, if I knew what r, p and t were, that would equal to 0, which means r is equal to pt. So that's not quite what I want. What I'm trying to show is back up here is pq, but it's close. So what I'm going to do is I'm going to take a look at this little section here. Well, the x's, so minus q plus t x plus 0x should equal to 0x. Now I'm going to factorize out the x's. In other words, they're all going to cancel. So I'll have minus q plus t is equal to 0, which means t is equal to q. So that means that this t here can be replaced with the q. So r is equal to pq. And that was the first thing that you were asked to show. Sorry. So there was a second part of that question. Second part of the question says, express the roots of the cubic in terms of p and q. So I suppose the bit that I want you guys to latch onto is the roots of the cubic. That means the answers to the cubic. Now, roots of cubics or roots of quadratics, they're always given in the form x equals to something. Okay? So I'm just going to flip over the page here. We have some information that we know. We know that from our division, basically we can say that x squared minus t multiplied by x minus p, that should equal to x cubed minus px squared minus qx plus r. Now to get the roots, basically this is a function y. To get the roots, basically we want that equal to 0. So we end up with x squared minus t, x minus p equals to 0. X squared minus t is equal to 0, or x minus p is equal to 0. So x is equal to p, there's one root. X squared is equal to t. X is equal to plus or minus the square root of t. Now, that's our second root. But just to finish the question correctly, it does say, express the roots of the cubic in terms of p and q. So I'm happy with this one because it's x is equal to p. I'm not happy with this one because it's not in terms of p or q. So what I need to do is maybe see if there's something I can use to change that around. Well, if you just flip back here, if you remember, you can say that t is equal to q. So taking that fact, I can say x is equal to plus or minus the square root of q. And there's your other two roots. You'll notice there are two roots here, and then this one is your third one, which fits in with some of the things that we know about cubics, having to have three roots.